So I'm here today to talk about re-architecting or architecting the data center for the future using a set of technologies that Intel has been working on for a number of years that we call Intel Rack Scale Design. And there's a couple of things going on in the market that I want to really take you on a journey on. Explain to you what's happening in the market, how we see partners such as SafeDX responding to that demand, responding to the changes in workloads, the changes in technologies that are created by the flood of new services that might be AI-driven, that might be driven by machine learning, that might be driven by software-defined networking. And then what kind of key technology trends that we're seeing and that we're providing solutions for as Intel. So let's jump right in. So one of the key points that I want to lead off the conversation with is that Intel as a company is changing to become much more of a data-centric company. And data itself is driving innovation both at the technical as well as at the business level. In fact, it's transforming the way electronic business is transacted today. And let me give you a couple of proof points and examples for that. First of all, you've all heard these statistics about the number of connected devices, internet-connected devices, that are constantly increasing. And many analysts have provided statistics about how many billions of devices will be connected to the internet, and therefore creating a need to not only capture information, but to process it, to analyze it, and then to display it at any time on multiple types of device types. So 50 billion connected devices is kind of a common number that we use within Intel. And whether that number is going to be accomplished by 2020, 2022, it really doesn't matter. It's going to be a very large number. The second key trend that we're seeing is the transformation of the network. The transformation of the network towards software-defined networking, network functions virtualization is one thing that is really undeniable and it's underpinning a lot of the key technologies such as 5G that are being brought into the network. Right? So we have some statistics, for example, that by 2020, actually 2022, 20% of all networks will be virtualized. And with that, you have a fundamental new set of technologies that are really driving the cloudification of the network. A third key trend that we're seeing and that's really underpinning the development that data is driving innovation as well as business transformation is the growth of AI and analytics. And a very popular example here is that of YouTube, right? So with YouTube, every 3 seconds, about 15 hours of video is uploaded onto the YouTube data center. And analyzing all of these images and this video can only be done using artificial intelligence and analytics engine. So this overall deluge of data is really changing and transforming the way business is being done. And it's also causing a need to re-architect the way data centers are built. And there are really 3 key challenges or 3 objectives. I call them the ESA objectives, like the European Space Agency, that really need to be resolved. First of all, these new data centers have to be efficient, they have to be scalable, and they have to be agile. And take some water. So this kind of diversity in the workloads is driving a trend in data center architecture called heterogeneous computing as well, right? So to give you a little bit more depth to some of the assertions that I said, right? The network transformation is expected to add 1,000 times more capacity need to existing data center capabilities. Artificial intelligence is going to directly impact the number of compute cycles, and we estimate about 12x that is required. And visual computing, right, we're going to actually have some showcases on visual computing and analytics engines. That digital content creation and delivery is also going to radically change how data centers are going to be architected. And with that change, really comes great opportunity. The opportunity right now is for companies such as Intel to provide the right level of guidance to help you with three things, right? Place the right workload, or use the right technology to place the right workload into the right cloud environment, whether that is a public cloud environment or a private cloud environment. It's also one of the key assertions from Intel is that it's time to rethink the data center. Today, if you look at existing kind of cloud architectures, the way they're built is that the server is ultimately the unit of purchase. What we're seeing more and more happening is that the rack is becoming the unit of purchase. And that is driven by technologies such as rack scale design architecture. And I'm going to go into more details on what rack scale design actually means. But to give you a little bit of a visual here, you have a network component such as a TOR at the top. Then you have a pool of compute resources. You might have a storage drawer as well as an accelerator drawer. So you decompose the key elements that you have traditionally in the server and start to pool them, which can drive the efficiency and the utilization of these resources. So, rack scale design is a critical part of the solution portfolio, and we're going to show you some demonstrations later for some storage pooling scenarios, but it's not the only thing. And again, if I'm losing you, I'm just not liking the mic. So having a flexible rack scale architecture is one of the key pillars for a hyperscale data center. But there are two other key parts of that solution portfolio that Intel is providing. First of all, it is solutions in the orchestration and management space in particular that provide efficient resource management, being able to use OpenStack, Kubernetes, or similar solutions to ideally place the right workloads onto the right Intel hardware. And then secondly, it's also absolutely critical, and Martin and I and his team, we had a conversation about this, is that these solutions make it very easy to very quickly and seamlessly deploy workloads that are very much tailored and can be monetized for particular customers, whether these customers are in the healthcare space or in the financial services space. So these kind of key sectors, rack scale design, efficient resource management, and having solutions that accelerate deployments kind of all go together. So let's go a little bit more into depth on rack scale design. One of the key things that I mentioned before is disaggregation and composability. And those are really needed to create what we call an optimized SDI infrastructure, so a software-defined infrastructure, which exposes the hardware components as well as places workloads as efficiently as possible. From an API perspective, everything, of course, should be based on available standards, such as Redfish, for example, so that you can have a multi-vendor scenario purchasing servers not only from one company, but from multiple companies, and have them actually work in an interoperable way so you can place workloads and move workloads, even in pooled scenarios, from one vendor to the other. And the disaggregated and composable reference architecture is important to drive efficiency. And what we mean by that is that the disaggregation allows you to spend less upfront, and then as the refresh cycles kick in for particular storage, compute, or networking components, you only have to replace what you really need, right? Today, with the legacy server, if you want to upgrade, you have to replace the entire server. With a disaggregated system, you only refresh what you need. And through the software capabilities in rack scale architecture, you can compose those hardware resources on the fly, depending on what the workload really requires. So we're going to show you a little bit of a demo during Technologist showcase as well. So one of the effects or really results of this disaggregation is that you can get back to one of the key challenges that I talked about before: efficiency, scalability, and agility. You can not only physically put all of your compute pools together, all your, in the future, accelerator pools, right, if we're talking about GPUs or FPGAs, and then upgrade these pools independently, allowing different refresh rates. Okay. So let me now switch gears a little bit, because we kind of started talking about rack scale design and what is available today. I want to spend a little bit of time also hitting upon some kind of broader technology trends that are impacting the way modern clouds are being built. The first one is the trend to have larger compute, right? With SafeDX, we now have a system that has about 256 servers. Clearly, there's tremendous growth potential now to extend that system, to data centers that have thousands and thousands of servers, right? Now, again, coming back to the original point, this kind of trend to have larger compute also means that you have more of a risk of stranded resources, and the efficiency problems that you might have with a traditional server-based model might actually exacerbate or be exacerbated by this trend. So having a disaggregated and composed infrastructure in your network can actually help you with this kind of trend towards having more and more larger compute to deal with more and more AIs, algorithms, and visual computing. The second trend that we're seeing is kind of the blurring of memory and storage hierarchies. That is also impacting how modern data centers and racks are being designed. Right? Historically, you had a very nice and simple pyramid where you have the HDD, say in a JBOD at the bottom, that had the high capacity but low cost and reasonably low performance as well. SSDs in the middle, and DRAM at the top as the most expensive kind of memory option. This is now being revolutionized and changed, right? Particularly with solutions such as Intel Optane, the line between DRAM and SSDs is becoming very blurred. And the advantage to building a modern data center is that you can now very efficiently access memory directly without having to go through the traditional kind of routes to access HDD. So as these new technologies are coming to market, we call them 3D crosspoint DIMMs or Optane-based SSDs or 3D NAND, the top part of this pyramid is really becoming blurred, and storage pooling is becoming much more efficient and cost efficient than what it used to be. The next kind of a major trend for rack scale design are accelerator pools. So accelerators, from an Intel perspective, often means FPGAs, which are field programmable gate arrays. And Historically, there are some limitations as to how many FPGAs you can fit into a server and use the existing PCIe-based system to access all of these FPGAs at the same time. One of the key things that is going to hit the market very soon is FPGA pooling, which allows you to share the workload and the available hardware across many different use cases. Whenever you need access to FPGAs to process and analyze a particular AI scenario, HPC scenario, you can actually use accelerator pools. And accelerator pools, again, are going to be tightly integrated into the overall rack scale design architecture going forward. So I want to invite you to learn more. Rack scale design is clearly a complex topic. There's a lot of resources available from Intel to educate you and inform you about what it is, what other customers worldwide have done. There's also some white paper information from SafeDX about this, and learn more. And also want to create a little bit of a buzz for Adrian's demo in the showcase part of this presentation, where we're actually going to show you a live demonstration of an NVMe-based storage pooling scenario for a genomics type of application. All right, and with that, thank you very much.